Hi there and welcome back to the Good Tutor SAT Premier Prep course. And today we're going to continue our look at the Heart of Algebra section of the SAT Math sections. And we're going to take a look specifically at solving linear inequalities, which you're going to find are very similar to the equations we've already been looking at. So we're going to go through a little bit of a lesson part and then several examples as well. All right, so for a little bit of introduction, the main difference between our equations, those linear equations we've been looking at, and now the inequalities that we're looking at, is basically our answer is ultimately going to be a range of values instead of just one value. So greater than a certain value, less than a certain value, greater than or equal to a certain value, or less than or equal to. Now, it's an important distinction to make that we actually do still put these inequalities in that slope-intercept form that we learned about with our equations. You remember y equals mx plus b? Well, now it's just going to be y inequality symbol mx plus b. And in that space, again, can go greater than or equal to, less than or equal to, which I wrote out of order there. So greater than or equal to, less than or equal to, or less than, any of the inequality symbols can essentially take the place of that equal sign in the slope-intercept form, but everything else will be the same. X and y will still be the coordinates of a point, like x, y, and m will still be our slope, and b is still that y-intercept. So it really won't be any different as far as slope-intercept form, and then this will help us, of course, to graph them most importantly as well, and not just solve. So now if we want to look at a couple examples, the first of which we'll look at, and we'll practice first just solving for a value of x. So 4/5 x minus 3 is greater than or equal to 4. All right, so again, no different than a linear equation that we were solving. We're going to try and get x isolated, or get x alone. To start, we will add 3 to both sides, which will leave us with 4/5 x is greater than or equal to a positive 7. All right, from here, we know that right now 4/5 and x are being multiplied, so we'll have to essentially do the opposite, or in this case, multiply by the reciprocal, right? It would be usually dividing by that leading coefficient, or in this case, because it's a fraction, we'll multiply by the reciprocal, which would be 5/4, which means both sides have to be multiplied by 5/4. All right. And now we'll have x is greater than or equal to whatever 7 over 1, 7 as a fraction, times 5/4 will be. And that would be 35/4, which cannot simplify. So x is greater than or equal to 35/4. And that's how we would solve that one. All right, let's go ahead and do one more example, and this will show you a rule that really distinguishes inequalities from linear equations when it has to do with multiplying and dividing by a negative number. All right. So this example will be -6/7 x plus 3 is greater than, or less than or equal to, rather, 2. -6/7 x plus 3 is less than or equal to 2. All right, in this case, we'll start very similar to the last one. This time we'll actually have to subtract it by 3. So we'll have -6/7 x is less than or equal to, now, -1, right? Because that 2 subtracted that negative, or that 3. All right, and from here now we know that -6/7 and x are being multiplied, which means we'll have to divide by -6/7, or again multiply by the reciprocal, which would be multiplying by -7/6. Now it's important to note, anytime we multiply or divide by a negative number in an inequality, such as this one, we have to switch or flip the inequality sign. So anytime All right. So in this case, we will still multiply that by that reciprocal of negative 6/7 both sides, but we will have to flip it. So these two will cancel into 1. So now x, and then don't forget to flip the less than or equal to greater than or equal to, will be negative 1 times negative 7/6 will equal a positive 7/6. So now we know that x is greater than or equal to 7/6. All right. So that's an important rule. So if you're taking notes, I would suggest writing this down. This rule right here. All right. The last part that we'll get into in this video is graphing linear inequalities, okay? Again, because they're already in that slope-intercept form of y inequality sign mx plus b, we'll know our slope, so how our line will move, and then as well, we'll also know our y-intercept there at b. So that shouldn't be too bad. The main difference will just be which sign we're using, either of the greater than signs, greater than or equal to, or less than and less than or equal to. Depending on which one of those will depend really what our graph looks like. Because in inequality graphs, we have something known as shading, and that has to do with having a range of values be our answer, as opposed to a single value. So let's use the example y is greater than 3x plus 1. All right, so we would graph this initially no different than we would graph the line of the equation 3 equals, or y equals 3x plus 1, right? Our y-intercept would be 1, and then our slope would be 3, or 3 over 1, so 1, 2, 3 rise over 1 run. 1, 2, 3 rise over another run. Just like that. All right. So now we would have that line. We would graph it, no different. But because this is not just an equation, but rather an inequality, we now have to look at, okay, this is a greater than equation or inequality. That means we will shade above the line like this. And that's where shading comes in. So for greater than and greater than or equal to, we shade above the line. However, if we have less than or equal to, we shade below the line. And to just show you one of those, we could do y is less than or equal to negative 2x minus 1. We know negative 1 is our y-intercept, and we have a slope of negative 2, or negative 2 over 1, so down 2 over 1, down 2 over 1. All right, there we go. We have our line, and now because it's a less than or equal to, we'll shade below that line. There we go. All right, and that is how you solve and graph linear inequalities. And up next, we'll look at word problems dealing with linear inequalities.